Hello, my DevNation friends from everywhere in the world. Welcome to another Tech Talk. Today's subject is all about metrics if you want to know more about your application. And we have a very special guest. She's super excited to be here. She's ramped up already. So, Erin, welcome to the stage.
I'm just a little wound up. I'll see how it goes. We'll see
All
how it goes.
right, Erin, I can see that you have a very nice t-shirt. What is that?
This is from the Quarkus World Tour. We've been doing those all over everywhere, and yeah, it's been a good time. Not just me. I've only been in a few, but we've got people everywhere, and it's like 3/4 sleeve t-shirt. Super, I love it.
Yeah, just in case you didn't see a Quarkus World 2 near you, well, you still have the opportunity, so you can have some amazing speakers like Erin talking about Quarkus. Yeah.
And you get a
And
cool
Erin,
t-shirt.
yeah, you might get a super cool t-shirt. And Erin, are you a cat or a dog person?
Dog person. I'm a dog mom.
Okay,
Dog mom.
cool. Yeah, I think I'm a dog person myself. Well, but without any further delay, I would like to leave you to the stage. Erin, the stage is yours.
Thanks. So, hi, I'm Erin. I would like to make sure that if anybody watching has questions, please feel free to interrupt me. We have on the books about a half an hour. This is going to be really dense, but I hope you leave this talk with everything you thought you needed to know, or at least enough interest and enough context that you can go look for more. We'll see how this goes, but if you have questions, please ask. I love being interrupted, so just do the thing, and we'll conquer the universe, and it'll be awesome. So when we're talking about metrics and why we need to know our application to begin with, we're usually talking within the context of what makes a system or your service within a distributed system context observable. I have some common pieces in here. There's active discussion right now about whether or not the 3 pillars term is useful or not. Well, me personally, I include a 4th pillar because I think your health checks count as one of the many ways you make your service observable. But when we're talking like health checks, are you a zombie, right? Are you ready for work? That's one way your, the automation around your service can understand how to deal with your service and whether or not it's ready. So that's one factor. When we talk about logs or we talk about traces, right? That's all of your super detailed, context-rich information about either how your individual service is behaving in the case of logs, or how your service is behaving within the context of a larger application in the case of distributed trace. So both of those are super important for problem determination analysis. How do you figure out what is going on when something is not working well? So the piece that we're going to talk about today specifically is metrics, which is not any of those other things. So when we're talking about metrics, we're talking about time series data, which is a fairly compact storage format, right? When we look and deal with this data, time is the x-axis. You're operating on regularly gathered numerical values, right? Where the whole point is you do an additional scrape, it grabs an additional measurement and appends that to the end of the time series. And then over time, right, you have this nice sequence of measurements. And what you use that data for is looking for trends. It's trend analysis, anomaly detection, alerting. You're not using this for debugging. You're not using this for root cause analysis. What you're using this for is, did I do, like it can help you spot that something is wrong, but then you need all those details to figure out what is wrong, right? It's, did I make a change that was useful? Did it have a negative impact or a positive impact? You can tell that from trend analysis and anomaly kind of detection in terms of looking at these big trends. But again, you're not going to know exactly what it is. So you need more detailed analysis and more detailed data for that. So purpose-wise, be deliberate when you're thinking about metrics that you're looking for big, broad trends rather than specific instance kind of information. As part of dealing with that data and figuring out how to identify these trends and how to work with these trends, we talk about dimensional data. So again, you have like a string, like the base measurement, right, is a string name and a single numeric value, and then you keep adding to those time series. But we have further attributes that we use now in most systems. Almost all systems now have moved to this notion of dimensional data rather than a hierarchical naming pattern where you have information in the name. They're almost always, everybody's moved towards this dimensional model where I can specify additional attributes. In this case, this is HTTP server requests. So I can say what environment I'm running in, as an example, what method was used, what outcome. Outcome is an interesting thing we can talk more about later. Like what the outcome of the request was, what the specific status code was, and then you can see I have an example here of the URI. Now, when we talk about cardinality, which you will hear often when you talk actually either about metrics or about tracing, when we talk about cardinality, it's how many unique events, we could say, map onto one measurement. So if it's a one-to-one mapping, it's high cardinality. You have a unique thing for everything that happened. And that can be really powerful, but it's a lot of data. So it's just way too much data. So what ends up happening is we say you want to control cardinality by mapping several things onto one measurement. So like in this case, just looking at the data that's on the chart here, I'm using a template value for the URI, which means that any request that matches and lands on that URI endpoint, all those measurements are going to coalesce into this counter, right? So that's how we control cardinality, is we start mapping things down and gathering things together. So there's a balance that has to be struck with how much cardinality is okay. Don't be afraid of it. You can get a lot of data. When people talk about cardinality explosion, which you will hear about, it's because you ended up using an attribute that had an unbounded set or a overbroad set of possible values for those labels, and so you ended up with just way more data than you wanted, and it's too much. So you have to figure out how to narrow that back down so that you're controlling the amount that comes out. There's a number of ways to do that. But it's, you kind of have to experiment a little on the side and make sure that your balance of information you're gathering is right. But don't be afraid of having somewhat high cardinality data if that's what you need. Okay, so we're going to come back and talk about micrometer in this context now. And on the right side of the picture here is a screw gauge micrometer. This is a physical device that used to be in my dad's toolbox when I was little. And it's for really precise, fine measurement of screws or threads and screws or whatever the heck you need to measure. It's really super fine. And that was the inspiration for the name for micrometer, the library. I'm hoping as we get to the end that we'll explore a little bit about what makes micrometer vendor neutral. But I do want to mention at the top that the vendor neutral, the vendors we're talking about are observability systems. So that could be Datadog, Splunk, New Relic, LogDNA, StatsD, blah, blah, blah. Like there's a whole big growing list of observability providers, and that is the level, though that's the set we're abstracting over with micrometer. So this is where things are going to go fast, but I want to give an overview so that you as developers understand the options that you have for instrumenting your application, and then we'll circle back and I'll show you how I use these things. So in general, with micrometer, you get a meter registry. With Quarkus or with Spring, you're usually injecting that with either CDI or as a Spring Bean, and then you use that registry to create or reference or access meters. And there's a couple different types. We'll go through those in order. Counters are the easiest. You increment a counter. This is monotonically increasing data, never goes negative. What you'll see here is the general pattern. We'll go through the next couple and they'll look the same. So we won't have to go through those in detail. To register a counter, for example, you get your registry, you create a counter. This is it's the simplest way to make one. You use your name, you specify tags and value, tag value, tag value, and then at the end, you could just increment it right there. There's also usually a Fluent builder for it, which would allow you to specify more attributes, the base unit, the description, additional tags, and then you see that register, and you register this counter that you built with the registry. What you need to understand is that doesn't necessarily mean you create a new one. It's going to take the name and that combination of tags and it'll only create a new one if one isn't there, right? And this is, again, that cardinality question, where the name plus the unique combination of tags is what leads to a new time series, a new counter, or not. So it's basically a create if absent kind of pattern. The other option for counters is that you might have an annotation, where with that annotation, you're doing a name and the extra tags, and it'll count basically them. It's a method level annotation. It'll count the number of times that method is invoked. It's important to note that the annotations provided by Micrometer are not always supported. In the case of Quarkus, in the case of Spring Boot, those annotations are connected to things. But if you're using another framework, they may not do anything because you don't have anything that's doing the binding or the intercepting to actually make it do stuff. So you just have to bear that in mind. Why you would use one or the other? I prefer to use the first two. I do not use the annotation-based counters very often because I find more value using tags that are populated with the results of what I've been trying to do. So rather than saying this method is being called with some arbitrary amount of tags, I wait until I'm in the middle of the method so I can say this method was called with this parameter and this happened, right? And it within a cardinality boundary, of course, but I find that more informative. And the annotations, the a priori definition of annotations of tags in the annotations, I just find not very valuable. So that's that. If we take that same pattern and apply it to timers, you again have a convenience method, you have a builder pattern, it's very similar. And then timed also has an annotation with the same caveats applying. That's timer. Now, timers are used for duration. Yeah.
Let me interrupt you a bit. We
Sure.
have a question. Adolfo is asking, what of those are aggregable?
For counters are aggregable, always. Monotonically increasing value, always aggregable. Timers, and there's a caveat here. So I may ask Adolfo, I may say we'll come back to it, but timers by default in Micrometer collect three pieces of data. They collect a count, aggregable, a sum, aggregable. The max is tricky because the max is the maximum value observed over the previous time window, which by default is 2 minutes, which means you can't aggregate the max, you can only observe it. Because it'll go to 0 periodically. So it's not something that you can aggregate well. With timers specifically and distribution summaries, which we'll get to in a second, you can, it's not on by default, you can enable additional statistics. And of those additional statistics, histogram buckets are aggregable, quantiles and percentiles are not. And that's because you've lost the intermediate values. Like those values are calculated within what this specific instance of a service knows. And you can't, the scale doesn't go out to other places. You can't redo that. But if you have histogram buckets, those are just sums. They're just counters in buckets. And those can be reaggregated, right? So I think that answers the question. We can come back to it again if it doesn't.
Sure.
But I think that should be it. Now with timers, because you're dealing with durations, the API for timer has a bunch of methods that help you work with timers, right? So you can record a runnable, you can record a callable, you can create, it will help you create a runnable or a callable that you can then just keep using as you need to, and it'll have the wrapper around it. And it also has a sample, so you can start and just keep the sample for later, and then use that sample to stop the timer, and it'll carry the context forward. As a library maintainer for the Micrometer extension in Quarkus, I use that last one all the time, right? Because where I have to intercept to add, to start a timer for an HTTP request coming in, for example, I can't wrap anything. I'm in the middle of a big async flow, so I just have to remember that sample and then stop the timer on the sample later. So. But all of those convenience methods are there to make it easy for you to time whatever operation you need to be timing. Okay, gauges, I've got some, we're gonna go back to a couple concepts after this, but gauges are interesting because they are observed at like, it's like you don't know the value until observation time. So either a Prometheus scrape will observe the value, or in the case of Datadog or others where they want a steady cadence of push, they're more the push model. It's whenever that timer pops and they'll observe all the gauges and grab the value, so you don't know what the value is until it's pulled. And the interesting thing about gauges is, like, one of the uses is observing the size of a collection. So Micrometer has some helper methods. Oh, you want to observe the size of a list? Well, here, I'll help you make your list, and then it'll just observe that list as part of, just as part of helping you create the list. The other thing you're often looking at is additional, like you're looking at existing objects with existing methods. So this second example, using the fluid builder of a gauge, for example, is that I'm going to invoke an existing method, the get peak thread count, on the instance of the thread MX bean at scrape time. So it's allowing me to hook existing methods on existing objects into the metrics system. And this is super useful for library maintainers, for example, because you can use whatever, and we'll see a couple examples, but it allows you to observe existing objects to do that. So this is a gauge, and again, you use these on values that drift up and down. So this is one of the first times you see negative values, right? You're just observing whatever that object is at the time, like whatever that count or attribute, whatever that value is at the time. And it doesn't have any guaranteed trend. These are numbers that you can't sum either, right? It doesn't really make sense for you to add some of these numbers, like CPU temperature. Like, you can't add a cumulative temperature. It's not what you do. Function gauges, or function counters, here we're saying we have a monotonically increasing function. We know it behaves like a counter, but we're going to create one as we would a gauge, which is, in this case, this is what Hibernate uses. Hibernate has a statistics object already that's maintaining its own counts. And so we're using a function counter to observe the other counter that exists. So we don't have to create a new counter just to make Micrometer happy. We can use the counter that the library already has. So that's super cool. A function timer is similar. It's a little trickier. These are two monotonically increasing functions that go together. In this case, I forget which cache implementation it is, but they already track the number of operations against the cache, and they already track the latency of those operations. So we can basically construct a virtual timer by collecting the values of those two functions at observation time. And so you can kind of pretend you mock up a timer on the fly by observing something that already exists. So that's that. Long task timers, this is the last type I'm going to go over, so we're almost done, are super, super cool. I have a really strong tendency to want to do them everywhere, but they're a little off the beaten path, so I hold back. The cool thing about long task timers is, in the same way that a timer does, they give you a count and a sum and a max, but it's what those three values are that are interesting. The count, in the case of a long task timer, is the number of active tasks. Remember, you have to think about this in terms of long running tasks, like a batch job, if that's the first way you want to visualize this, right? It's the number of active tasks. And then the sum is going to be the cumulative duration of all of the active tasks. So one is taking 30 seconds, one is 5 minutes, right? You add all of those together, and that's the value of your sum. It's like a gauge, though, right? Or it's, it increases monotonically. It does increase because you don't ever go negative, but it's the value of the cumulative value of the tasks that are running. The third one is, actually, no, I think it is treated as a gauge, as a value. The third one is a max, and it is the duration of the longest running active task. Now, why is that useful? So if I have batch jobs that run, I expect them to run for an hour, but something has happened and they're running for an hour and a half, I can alert on that max value that says, oh, the oldest task it's been an hour and a half and it's not done yet. I can get that alert before the hung task takes 3 more days to never finish, right? It's like I can alert as soon as it's beyond the bound of what I would expect, even if it's still stuck. Which I can think of a whole bunch of other places where I am thinking I might want some of those, like measuring queue behavior or any other thing where you're worried about knowing when something is starting to get stuck. Of course, there's trade-offs with, metrics are not free either, right? You have to understand when you turn metrics on, there's there are storage, you are incurring some cost, so it's not free, but it may be worth it if you're trying to figure out whether or not things are stuck or getting overrun, or pick a thing. So it's pretty exciting. I have like 5 different places right now that I'm in the back of my head thinking about where I want to put long task timers. So there's that. Okay. Oh, distribution summary. I forgot these. These are the same as timers, but they're not for time. That's it. You get some, you get the count and the sum and the max, just like you do for timers, but these are for other things, like how many bytes each response sent, or how many, or, pick another thing. You still have values in this case. You're looking at the distribution of values, but they're otherwise the same as timers. They look and feel the same as timers. The meter filters to turn on additional metrics are the same as timers. So that's it. I talked a little before about the library maintainer API, where some of those meter types are useful for meter binders, or for library maintainers. And then within Micrometer itself, we have a bunch of meter binders for libraries, for common libraries already defined, if you want examples, but that's the essence of what a library maintainer needs to know. Meter filters we talked about. Yeah.
Interrupt you again. So
yeah, no, go for it.
Another question from Adolfo. Do I need to know where to put the long.task time annotation?
So this annotation is the same as you would use the normal timed annotation. It's a method level annotation, so it's not on a field or anything like that. It's a method level annotation, and it would say this method is a long running task, basically. So it flips from just a normal timer to this long task timer, and so the data that you get out then is different. So it's still a method level annotation, if that makes sense. And that you can see it's exactly the same as the other. Here, let's flip up. The timed annotation is the same. You still have the value, you still have the tags. It's just that long task annotation, or the long task attribute at the end, which then changes the kinds of metrics that are measured. In both cases, the annotation will handle completable futures. Both timed annotations will handle completable futures and will indicate, so you could do asynchronous or synchronous methods with the timed annotation. And if there's a completable future involved, it will take into consideration whether or not that completable future was successful or not. That makes sense.
Yes, totally. Thank you.
Cool. All right, ask more questions. I love being interrupted, especially since I feel like I'm just vomiting information right now. It's way better when somebody's like, no, wait, how about this? Okay, meter filters we talked about. They're just super powerful. They give you, within your application, the way to change how metrics defined by all these libraries, instrumented libraries, behave, right? So it just gives you, as the application developer, ultimate control over how this stuff works. So that's super good. You can, we already talked a little bit because of the question earlier about what numbers are aggregable or not, but Micrometer does support computation of percentiles and quantiles. You can set SLA boundaries, and you can do a bunch of stuff. It's just not all on by default because there's cost associated with doing all that extra stuff. And so they defer making you have to decide whether or not you want to incur that cost until you say yes, right? So it's just that extra storage and the extra calculation and the extra computation is not done unless you opt in, basically. Okay. Wow. See, I told you 24 minutes. That's like the laundry list of things. So this talk started a long time ago. I wrote this ridiculous app because I needed to learn all of Dungeons and Dragons rules in like next to zero time. And I write ridiculous things. So I made an app for that. And it takes stat blocks, monsters, and smashes them together, makes them fight a lot, because it gave me a lot of data to play with, to look at how counters and timers and all this stuff, not so much timers, but how these data types behave, how the data comes out, what it looks like. And it's not like stuff I just ingest from, copying and pasting from docs. I had to actually think about it. So as an application developer, if you're like, well, what would I use this for? So I know I'm off in the weeds already. Who else is gonna write a game that makes monsters and fight each other. Like, well, how does that apply? So let's look at this just a different way. So firstly, I was doing some exploratory stuff. Within my application, a core capability is rolling dice. And I wrote a bunch of stuff. We will flip through the code in a second. But I wrote a bunch of stuff to figure out how to roll dice, and then those are used all over the place. And so right here, you can see the code to create a counter for dice rolls. And what it's doing is, it's recording every time a dice roll finishes. It's recording, okay, this is the die that was rolled. Here's the face that was rolled on a die. So, and then it increments that counter. So I ended up being able to plot out for each roll of the dice what was happening. And this is one of the things when you talk to the Micrometer team too, they'll laugh. The first time you turn on metrics and you start measuring things your application is doing, you will find bugs you did not know that you had. I screwed up. I'm sure had I been smart and had a pair programmer, this would not have happened. I forgot to put the D12 in one of the switch statements that I needed. And so the numbers came out. I'm like, what did I do? Like, that's totally wrong. And I had written tests, like I had done all this stuff. It was a complete oversight, and it just popped out and smacked me in the face when I looked at that graph. I was like, oh man, whoops, that's not so good. So that was, number one for putting metrics on my own application for a core function, which was dice rolling. Now, this is total nerdness, but attacks in Dungeons and Dragons, there's different kinds. D20s, like if you roll 20, it always hits. If you roll a 1, it always misses. There's different ways to attack against an armor class versus a difficulty class, right? There's different kinds of hits and misses. And I had to try to, this was like the core of what I was trying to learn at the time. I wanted to make sure I understood how these monsters were supposed to work, what the rules were, how I was supposed to calculate and compare against which number. I wanted to make sure that when I'm DMing for my kids, like they're not waiting for me to go remember how this stuff's supposed to work. So I have a distribution summary that looks at how these attacks happen. And if this is a case, when I mentioned it earlier, where I don't know the tag value a priori. I can't use an annotation for this, because the interesting thing for me for my application is what actually happened, right? Did this attack hit or did it miss? Was it an armor class attack or a difficulty class attack? What kind of damage was it? Was it lightning? Was it poison? Was it, I don't know. And then here in this case, the value that I'm recording is the amount of damage that was issued by that attack. And of course, we talked earlier that this is a distribution summary. I'm obviously not using time here. And so then I can plot those out. And so when I first did this one, some of this is total nerdy, but I have a calculation for, like, I munged how I reduce cardinality. I have 3 Booleans. Is it this kind of hit or another kind of hit? And I construct this string that represents the value of these 3 Booleans. I had done something wrong. Critical saved hit is not a thing, but it popped out in my graph, and it was like, I don't even know what I did wrong. I think it was when I was trying to put together how to handle these difficulty class fights. And so I had like, this is how the armor class ones work, and then this time I'm going to put this in, and then somehow that came out. Total bug. When I went back and looked at my code, I'm like, that is 3 a.m. in the morning, Aaron writing code, because that makes no sense. I don't know how that ever worked. And then I fixed that, and then I'm looking at the frequency, and I'm like, the numbers are still wrong. The critical hits and misses should not be more frequent than just a normal miss. The numbers are wrong. And I had discovered that it was a data entry, a data parsing problem. I had messed up my regular expression. And so I had a maximum armor class of 9, which is why the hit number is so high and the miss number is so low. I had written unit tests. I knew the flow at that point. I had fixed things, right? I knew the flow of the battle was correct, but the numbers were totally wrong because I had made some other dumb mistake at the data entry point, which, I tested that too, but I didn't test to make sure the value was more than 9. I mean, yeah. So if we go and play, if we have more questions, I'm happy to have them. I can show you, like, within the dice rolls, I have these services running. So like Spring Boot and Quarkus are both running. If I look at metrics, let's not do it that way. Let's look at the Prometheus endpoint for Spring Boot. Right? See, we have JVM statistics. This is the kind of information that comes out, right? I have my encounter. There's a bunch of stuff I can look at for encounter. In this case, I'm not going to go into details about it right now, but like when I was designing encounters, or when I was trying to write up how these monsters were going to fight each other, I started to figure out, like, I'm making decisions about how one monster chooses the other monster that it should attack next. And so I'm like, then that, I wonder if that impacts how many rounds an encounter takes, for example. And this was another one I looked at, which was the maximum difference in size between the smallest monster and the largest monster and the smallest monster, right? With the general idea being, if the monsters are really different in size, it's going to be a one shot. The big monster is going to take the little monster and go smash, and that's it. But if they're the same size, who knows how long it'll take, right? Could take a much longer time. And it was that kind of information that I wanted to play with. So that data all comes out. I have, that's the max value. So you can see with Spring, right? You have your HTTP server request count. You have, here's some more damaged sums. Damaged sums and counts, right? With Quarkus, we have the same, more or less the same data coming out. We have JVM stuff. Of course, I'm actually applications, I'm using exactly the same metrics library. I can show you what my metrics thing looks like. But these come out the same. I have, where's my HTTP requests? The HTTP request data is shaped the same because it's using the same library, and Quarkus has the same. Okay, the question, yeah, I see it. If you want to use Elastic's Kibana instead of Grafana. I think I have not done that yet. No, this is not the one I want. Let's go look at Micrometer. So within Micrometer, of course, it has its core, which is where the common binders and stuff are, but it also has a list of implementations. And so when I talked earlier about there being different, like it's vendor neutral, right? This is where it can support a whole bunch of different kinds of backends. And so I'm not sure how Elastic would collect metrics data. So I don't know the answer. With Elastic, it's right here. I'm like, there's an answer to this question. There is a backend for Elastic. So what you would do is you would have the Micrometer core library, or in the case of Spring, you would turn on the actuator. In the case of Quarkus, you would turn on the Micrometer extension. That gives you your core metrics and integration with the runtime in both cases. And then you would enable the Elastic registry. I don't have the Elastic registry set up for Quarkus yet. We have a Quarkiverse. Oh, look, it's down there. We have a Quarkiverse extension, Quarkiverse repository that has Quarkiverse extensions to help get these different registries prepared to run in native mode, for example. It's facilitation basically for hooking these different registry types in. But you should, if you're not in native mode, you could just as easily turn on the Quarkus Micrometer extension and then just add the registry dependency to your application. So in your case, if you wanted to use Elastic, you would turn on the Elastic registry and then it should emit, and Kibana should be okay with that, I think. I haven't done it, so I could be wrong.
We have another question here from Christian. In order to allow calculation of percentiles on the monitoring system, do you have to enable percentile histograms?
No, depends on the system. I mean, the answer is no, but it depends on the system. So Prometheus, for example, oh goodness gracious. Let's just go play with Prometheus for a second. I think Prometheus has, if you look at its functions, Which ones do I want? Crap. What am I looking for? Prometheus wants, I don't know which part of the piece I'm looking for. The query functions are what I want. I don't want the expression browser. I don't want that. I don't want that. What am I looking for? Metric types?
Okay.
Yes.
Yeah, and Christian
So-
is saying here that he uses Datadog. Do you know anything about it?
Right. So, right, that was what I was going to say. I just can't find the functions in my head, right? But Prometheus wants to do, I will answer the Datadog question in a second. Prometheus wants to do that calculation later. So Prometheus says the most you would want to do is emit the histogram buckets, and it will calculate the quantiles and the other things later. I think Datadog does have different rules about how it wants, what it expects you to emit in order for it to calculate that. I don't know it off the top of my head. So you minimally, I think, would have to do the histograms. I don't know that it wants, I don't know if it wants the percentiles or just the histograms. I don't remember if Datadog can do the percentiles. But I think.
But it's okay. Yeah, we don't have to know everything. And
Let's just see. It's got the step meter registry. It wants to publish. Here we can figure it out. Here's gauge, counter, visit, summary. Here's timer. So the timer is converting those into, when it's writing the summary, it's doing the sum, the count. It's pre-sending the average and the max. And then I think if you turned on additional histogram data, it would do that. Anyway, was there another question?
Yeah, I think we have one last question because we're already in the top of the hour.
Yep.
So, and I think this one should quick. Like, is the Spring version also using microprofile?
The Spring uses Micrometer. Spring Boot uses Micrometer. It doesn't use microprofile at all. Quarkus uses Micrometer now preferentially. Support for microprofile metrics is there. But from just the metrics library perspective, Micrometer is in both places. So the microprofile word is a little confusing for me, Adolfo. I'm not sure what you mean, right? Spring has its own API, its own programming model.
Mm-hmm.
It is.
Yeah, I agree. I think it's different APIs, different standards.
Yeah.
So, well, yeah. I'd like to thank you, Erin, for spending this time with us. I'm pretty sure everybody was super entertained and super informed after your talk.
I hope so. And you can find me. The Micrometer Slack has the Quarkus channel. I'm on the Micrometer Slack. We're in the Quarkus Zulip. Come find me. I'm on Twitter.
Mm-hmm.
I like questions.
Yeah, multiple ways to find Erin on the internet. Yeah.
Yeah.
All right. Thank you very much, Erin. And if you're watching this video, thank you very much for being here with us at DevNation, and see you at the next DevNation offering.